Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the topic, that is mechanism of reactions for class 11. Now this is part 3 where I am going to explain preparation of alkane from alcohol. Already I have explained in part 1 and part 2 that the addition of HBr to alkane and chlorination of methane. Now here, preparation of alkene from alcohol, what is the meaning? That means how we will get alkane from alcohol, and that is called dehydration of alcohol. What is meaning dehydration? De means remove. Hydration means water is removed from alcohol. Then what is the reaction? What are the steps? What are the steps of the reaction? That is called mechanism reaction, and how to prepare, that is your alkane from alcohol. So it is better to know what is mean of dehydration and what are the steps and what you will use as a reagent. Generally it is observed alkanes are prepared. What is dehydration of alcohol? From alcohol, water is removed by what method? By what method? By dehydration method. Dehydration means what here? Water is removed with presence of what? That is protonic acid. That means alkane can be prepared from alcohol by heating with protonic acid. Then come to question, what is meant by protonic acid? Protonic acid means the acid having hydrogen. Generally here the acids are used sulfuric acid. What is the formula? H2SO4. And phosphoric acid, you take this or that, not both. That means sulfuric acid you take, or you can take phosphoric acid, H3PO4. So it is better, I think, sulfuric acid the good. And temperature you should remember, that is 443 Kelvin. That means acid when heated, the alcohol when heated with protonic acid, especially that is sulfuric acid, then what happened here? Alkane is produced. See here, you are taking here ethyl. What is this? Ethanol as IP's name, and common name ethyl alcohol. So what is this one? Ethyl alcohol. And when it is heated in presence of sulfuric acid and the temperature 443 Kelvin, and this is produced, that is called ethane. So are you clear? And water, that is why this reaction is called dehydration of alcohol. But here, what are the steps involved? One by one, the steps you will see, and that is called mechanism of the reaction, that is preparation of alkane from alcohol. Now here you see first the step 1. What is mean step 1 here? That means how the alcohols attacked by the protonic acid. You know protonic acid contain proton, that is called hydrogen. How it will attack the that electron rich side of the alcohol. What is electron rich side of alcohol? You see, this is ethyl alcohol, and now oxygen is there and two pair of electrons are there. Here this is one pair, and here this is one pair, and this is one pair. These two pair of electrons are there, but only one pair of electron will go to H plus, because H plus be attached to the oxygen by taking two electrons from here. That is mean here you can see the hydrogen will come to here. This hydrogen come to here, and that changes to positive ion. Clear now? And now Ca3CH2, there are two pair of electron. One pair of electron that is attacks, this H plus ion attacks that through the pair of electron, and so and this is attached to the ethyl alcohol, that is called protonated alcohol. What is mean protonated? Because it is giving, you can see here, positive sign. So it is called protonated alcohol. Are you clear what is mean by protonated alcohol? Protonated alcohol mean the oxygen atom having deficient of electron and occupies the plus ion. That is the step 1. And now we will see step 2. What is mean step 2 here? Step 2 mean Here, protonated alcohol over, and here what is mean? Actually, protonated alcohol is very active. Protonated alcohol is very active. Immediately, it loses water molecule and give carbocation, and it is called carbonium ion. Carbocation and carbonium ion both have same meaning. So, if protonated alcohol loses water, it gives carbocation, that means C+. C+, here carbocation, I told different type of carbocations are there. That is primary carbocation where CS2+, where C acquires positive charge in CS2, that is called primary. Now this one you can see, this is primary carbocation. Similarly, if CH+, then it is called secondary carbocation. If only C+, there is no hydrogen attached, that is called tertiary carbocation. And accordingly, as I have given that idea that tertiary carbocation is more stable than secondary carbocation, and that is more stable than primary carbocation. Now you will observe what happens here, what type of carbocation is produced. Now here positive charge on the oxygen, and oxygen is more electronegative. If it is electronegative is more and electronegativity is more, then what happens? What is meant by electronegativity? That means it has tendency to attract electron towards itself. So what happens here, since electronegative tendency, electroaccepting tendency, that means it attracts electron towards itself. That means here electroaccepting tendency more than CO bond. The CO bond becomes weak, and this CO bond, now see this one, CO bond breaks easily. That is why the CS2, this part occupies positive charge. This part occupies positive charge. And now you can observe CH3, CH2, this is plus, that is called ethyl carbocation. What it mean? Ethyl carbocation, but it is a primary one. Now you can, here not necessary to compare with the secondary and tertiary carbocation. You can only observe this is ethyl carbocation, which is primary one. Okay, then the step is slow. Remember, when it produces carbocation, that is very slow step. In chemical kinetics, the slow step is the most important step for the rate determining. The rate can determine by the slow step, so it is very important that slow steps, it is very important for rate determining step. And now what happened here? It loses water molecule. That is where carbocation is produced, and this carbocation is very important, and that is very also unstable. Again, what happened? If it is unstable, then what happened here? That it immediately loses H+ ion. Remember, the carbocation is very unstable. I told you that carbocation is always unstable, but when you compare different type of carbocation, and this is very important. Now here primary carbocation, that is why it is also unstable. It loses a proton means H+, and from neighboring carbon and changes into ethene. See, here it will come to this side and H+ is removed. This is H+ proton is removed, and the product is here CH2 double bond CH2, that is ethane. Are you clear? That means ethyl alcohol, lastly it produces ethane. Then what is conclusion? That is the reaction. Ethyl alcohol, you can say ethanol. Ethanol is the IUPAC name, and here this is the ethene. So what is the conclusion? Here having 3 steps of the reaction, and what happened here? The last step is you are getting ethene. Similarly, if you see some important, that means addition of HBr to ethene. Here addition of HBr to ethene, what happened here? Now ethene, there are 2 hydrogen and 1 carbon left side, there are 2 hydrogen and 1 carbon right side, and that is symmetrical ethene. When you are adding HBr, H equals delta positive and this is minus delta. What is the meaning? That means bromine is more electronegative than hydrogen. That is why it equals delta positive. Delta means partial and here delta negative. Here see, this is again it acquires the positive charge. This is also called primary carbocation, and ethyl carbocation plus Br minus. Minus is separated. And again, this ethyl carbocation, you take Br, then what happens? It will attach to here. Are you clear? That means here it will attach to this. So again see here, first ethene, that means plus H plus Br minus, then here this hydrogen comes to here, and instead of 2 hydrogen, and this side occupies 3 hydrogen, and here the C plus carbocation, but it is primary carbocation, also it is active because it is not compared to others, and Br minus where it will attack, where there is a deficient of electron, that is positive charge across this positive charge, and here what happens, the Br is a negative part, negative charge, it will come to here, and this is called ethyl bromide. Then similarly, if you see addition of bromine to alkene, this is also very simple, and polarization of bromine molecule. Polarization of bromine molecule, here what happened, Br, a homogeneous molecule. If it is homogeneous molecule, then what happened here, this bromine molecule act as one side positive, other side negative, because both are same bromine, and here what happens, the CS2 plus, it acquires a positive charge, and CS2, one Br will come to this side, and this act as a carbocation, but it is primary carbocation, no problem at all. This is carbocation. And now in step 2, attack of bromide ion, because bromide is the negative charge, so it will attack to here. That means the CS2 plus, it is attacked by bromide ion and changes to CS2Br, CS2Br. What is the name? 1,2-dibromoethane. Again see, attack of bromide ion. Step 1, one bromide ion is separated, and one bromide, that the Br plus, it attached to the CS2 and produce carbocation. This carbocation, and this is very, very unstable, it attack to Br minus, it gives CS2Br, CS2Br, 1,2-dibromoethane. So what happened here, you can observe. First one I told about the dehydration of alcohol, and after that I told addition of HBr to ethane. Some reaction, I think, except that dehydration of alcohol, some reaction left, that one clear. And again you come to our first one, that is step 2. What happened to step 2? Step 1, that is mechanism of reaction of class 11th, that is preparation of alkene from alcohol. And you can see that is also preparation of alkene in 2 reaction I told. So alkene is prepared from alcohol by help of protonic acid. Protonic acid means containing hydrogen, and what happened, first step it produce your carbonium ion. This carbonium, that means first you will get protonated alcohol, and after that loses water molecule and changes to ethyl carbocation. It is very slow step. And after that here one hydrogen proton, that is H plus hydrogen plus, that is proton, and this proton that is released. Proton is released and it gives ethene. This is the proton. So conclusion is this one, on treating with the sulfuric acid or phosphoric acid at temperature 443 Kelvin, it gives ethene. And after that I want to say that is addition reaction, and this is the addition reaction, how the HBr react with ethane, how the second one is how ethene reacted with the bromine, and this is the conclusion. So I hope it is clear to you all.